here's a summary of the system that we're going to add jumping mechanics to. So, in the scene, we've got a player with a body mesh and a camera rig set up. Then, as in the script, we've got these settings here. I'll show you how those work. So, we store stuff like our movement speed in a struct called movement settings. We've got the look sensitivity in there as well. We declare it up top. Then in start, we assign the values of our current transform to move, and then in update, which plays every frame, we run this function, which calls these two functions. You can ignore the rotation one. The translation one takes our input and uses it to translate the player using this code here. So now, what we're going to do is we're going to set this up to use a rigid body. So I'll add a component, rigid body, set the mass to 80, though it doesn't really matter. Now in our code, what we're going to do is add, we're going to get the rigid body. It doesn't need to be serialized. We can just get it via scripting. So we'll just get it from whatever this script is attached to. This script is attached to the player game object, which also has a rigid body attached. We'll just make it require a rigid body, just to be sure. Require component type of rigid body. Now, every frame we call this movement function, which does a rotation translation. We're also going to do something that does jumping. So in this function, we'll say if you're pressing the spacebar, then do jumping stuff. But we're not going to get to that just yet. First, we have to change our translation to use the rigid body. Now that we're using rigid bodies, and this will allow your movement system to not walk through walls, which is always a good thing. So we'll set our movement equal to our x-axis movement times the transform.right, and do the same thing for the z-axis. This will allow us to use local space to world space transforms. So let's test out this new movement system we've just built. Press play, and you'll see that it tips around. So that's because we're using a capsule collider and our rigid body allows rotation. So if we just limit that, and let's just change our speed because this rigid body system will move slower than our translation one. So let's set it to 5. We're not tipping over because we've added those rotation constraints. And let's go back to the code. Now we'll add jumping. So if input.get key down spacebar is pressed, then we will jump. So we'll get the ms, that's movement settings, which we pass through both functions, .rigid body, rb, add force, and then vector3.up, that means the force goes upward, multiplied by our jump force, which we haven't created. So we'll go back to that struct where we added the speed and sensitivity, and we'll add a float called jump force, which we can set in the inspector. Let's do that now. Set it to 1,000. Now see what happens here. Is that we can jump even when we're in the air, and our translation function is getting called, which resets the velocity. So we're jumping, but then we're immediately slowing down. So we'll add a boolean, boots on ground. It doesn't have to be serialized because we're not setting it in the inspector, we're setting it within our script. And then we'll add this, on collision stay, and that means if we're touching the ground, then our boolean boots on ground equals true, and if we leave the ground, boots on ground equals false. Now we'll go to player underscore movement, and we'll set it so that we can only jump if movement settings.boots on ground is true. So we can only walk and we can only jump if we're touching the ground. And every time we jump, we'll set boots on ground to false. And this will return a boolean so that now our movement settings can know when our jumping function has changed the value of boots on ground. Then we'll also return our movement settings so that in the player.cs script, we can get those changes that we did in the player underscore movement. We might just get rid of on collision exits because we're already taking care of that in our jumping function. Okay, let's set that to 10,000, and you'll see 10,000 or even 1,000 is way too much, because now that our translation function is no longer immediately cancelling our jump in the next frame, it's actually doing the full jump. So 350, that's a much better jump height, much more realistic. Yeah, that works. So, as usual, please like, comment, subscribe, and leave comments about what you'd like to see in a later video. Cheers!